Thank you. Good morning, everyone. My name is Oscar Banos. I am the Director of Marketing at Amphenol Fiber Systems. I'm based in Dallas, Texas. As many of you know, Amphenol is a somewhat decentralized company by design. It's in our DNA. And with Open.Tech, it's a brand that we've built to provide an umbrella for the design community to be able to find a lot about VITA and SOSA type products. Within this group, we have about half a dozen different Amphenol divisions that are providing content for this group. And I just wanted to give you a little view on our idea of where the market is and where we think it's going, and we'd love to hear your feedback on what it is that you need us to give you next. So as far as the agenda, like I said, from what we see is everyone wants faster, smaller, more reliable. They want more of it. Used to be 24 channels of fiber was great. Now you need 192. Some people are needing more than that. We've seen a huge rise in the use of MT ferrules, and then we want to understand for the future, what is it that you want? Is it still, are we going to try to continue to extend multi-mode as far as it goes, or do we start looking at single mode, CWDM, DWDM, those type of technologies? And then how do we balance the data center, which drives the majority of this industry, with what we need in the military and harsh environment, which is a little bit at odds to each other. So this is by no means a complete history of connectors. There's well over 100 connectors that have been designed in the last 30 years or so. But most fiber optics, as modern fiber optics, started out in the mid-70s. There was programs that the Navy did to put fiber optics on an A-7 airplane. I think it was called the ALOF program. And that was kind of the start of seeing deployment of fiber optics in kind of harsh environment applications. And I believe, as I like to say, it's 50 years of hate of fiber optic connectors that started right after that. So, but in the 80s, we saw things like the ST connector started using ceramic ferrules, and believe it or not, the MT ferrule was developed in the mid 80s by NTT in Japan. So it's been around for quite some time. You fast forward to the 90s, we saw a huge investment by the telecom, deregulation of telecom, put a lot of VC money into the market, a lot of innovation in the 90s. You saw the advent of the SC connector becoming kind of like the standard in the industry based on 2.5 millimeter ferrule technology. Japan in particular is a really good source of very tight tolerance, low-cost ceramics, and that enabled a lot of connector design and improvements. So the LC, which was brought out by Lucent in the mid-90s, just basically mimicked what you had in an SC in half the footprint, and it just exploded. You had a multi-source agreement with the SFPs, and that ecosystem just kept feeding on itself, and you just saw this proliferation of LCs. You also had the MPO connector. It was already out in that time, but not being used as much as the single terminus type connectors. We also, for this relevant to our group, in the 90s, we saw the formation of the MIL-T 29504, which has since progressed into the MIL-PERF 29504, and that's what's still, I'd say 75% of the harsh environment business is still using some form of single terminus M29504 type termini. And then fast forward to the 2000s, we had the dot-com crash. Some of us are old enough to remember that, and was working in the industry. And there was not a lot of investment for a while until, we were waiting on the next killer app. It turned out to be your phone. And with the phone, and everyone wanting what they have on their computer on their phone, you saw this proliferation of the need for data and data centers and a lot of networking, and that just once again started a lot of investment. We also at that time started putting MTs into harsh environment fiber optic connectors because of about that time we started exhausting the ability of being able to do what we needed with the simplex type cables. So MTs and connectors, these are all Amphenol connectors. I don't mean to make this an Amphenol commercial, but we certainly aren't the only ones that make these type of connectors. But we were some of the original that did. So we've had our VITA, what's now committed to be a VITA 89 or MT38-9. It's a D38-999 form factor with a removable contact. We've had that in the industry for almost 20 years. It's got a lot of installed base. A lot of customers really like it. So there's that product. And then we saw TE come out with proposed VITA 66.X, which Amphenol also makes. So a wonderful board level type product that's enabled a lot of really compact packaging. More recently, we've seen the release of the VITA 87. It's also a product that TE originally made. And we Amphenol also have this product and are starting to ship it now as well. It gives you a very compact package, a very minimal protrusion in the housing with gang retention. As you notice, because we are a big company and we have different divisions, we make a lot of products that look kind of like almost the same, but they're different. And with that is like our MTC HD. This is a product that's a 38-999 form factor, a little better density than the VITA 89, not quite as good as the 87, but has removable contacts. So each MT ferrule can be individually removed, and we feel like there's a lot of value in that. And going further than that, we have a lot of rectangulars with MTs. So we have like a little D sub form factor, like our Nano DMT, or we have AirInc 600s with MTs in them, and things like EN 4165. So the advantages of removable fiber, for us, it's maintenance. There's a couple certainties in life. You know, there's death, taxes, and that you're going to have to clean a fiber optic connector. And at some point in the life of a fiber optic connector, you're going to have to clean it. So our philosophy is to design connectors to make that job as simple as possible. And we believe having removable fibers is one way of achieving that. There's certainly some drawbacks to it, but that's a choice that we let our customers make. So with removable fibers, we get to use components over and over. So if you need four MTs or 8 MTs or 10 MTs, we can kind of reuse this modular system over and over and just kind of place them in whatever form factor the customer needs. It gives us flexibility and scalability, and we believe that it helps with testing and validation, because it's very easy to remove a contact and not disturb a lot of the other system. I think there's some myths in the industry about that removable contacts aren't as reliable. We don't subscribe to that theory. Again, we have both. We have devices with gang retention, and we have devices with removable contacts, and we don't see any discernible difference in terms of mechanical robustness. They can pass the same levels of vibration. We do believe that eventually you will have to go in and have a remediation with the fiber and clean it. So we still do value being able to remove fibers. And even though it looks like you're adding more parts, in the end you really don't, because if you're thinking about doing a family of products and you have, say, 8 different shell sizes, and you had 8 different gang retention mechanisms, with a removable type contact, normally you would have just those 8 connectors, and then the same removable contact would be used over and over. So again, following on the concept of pluggable, we really like the pluggable type devices because they allow you a lot of maintainability and a lot of upgradability. So a little history on our onboard transceiver businesses. We have a group in Germany that has developed and manufactures these products. Starting back in 2009, we had the CFF, It's an LC duplex, pluggable up to 28 gigs device. In 2015, I believe we were the first in the industry to have the first MT form factor onboard pluggable transceiver. It's 12 sends, 12 receives. That product has been upgraded. We can now do 25 gigs per 16 gigs per channel, extended temperature, 28 gigs per channel at normal temperatures in this device. And in 2024, we launched another pluggable device called the QEPT. It's hot-swappable. It's got mezzanine connector to be able to plug it on the board so you can remove it very easily, and it has an MT interface, again, to allow for servicing very easily. Coming into 2025, we are extending the QEPT family to be at 200 gigs, operate at 200 gigs under PAM4, hot pluggable, again, common interfaces, pluggable, allows for maintenance, allows for upgradability. And what good does a connector do you or a transceiver do for you if you don't have a fiber connection to go in between? My group in particular focuses a lot on fiber optic cable assemblies. And so we have the standard solutions out there have been 1.8 millimeter fibers or even 0.8 millimeter fibers that we're seeing. Those are good for individual type contacts, but then when you get into MTs, it's been about ribbons, right? So you have 4, 8, 12 fiber, 16 fiber type ribbons out there. We have them in standard temperature and we have them in an extended temperature as well. And it's really important to match the right fiber with the right connector for the application. I guess it's somewhat obvious, but it truly, where we see the most problems is where we have a mismatch with a fiber that's not been designed for the connection system. And then when the off-the-shelf, increasingly the off-the-shelf solutions aren't adequate enough for our customers. They're saying, I don't have room for 12.8 millimeter cables. I certainly don't have room for 12 1.8 millimeter cables, and I need a ribbon that I can flex around corners and bend it, and ribbons don't do that very well. So for that, we're investing quite a bit in being able to do flex circuits, so we can custom design flex circuits to go around your obstacles and your modules. We can also make encapsulated cables. So again, the beauty of these types of solutions are they're pluggable. When you go to integrate them, you don't have to worry about the craft of how the harness was built and how you dress it out. You define your attachment points. We build a flex that drops into your box and plugs in on both ends. And again, if you have any problems, you can disconnect it. And then kind of the culmination of all these technologies and the desire for more is our switch product line. So right now we're offering things like a 64 channel, 50 gig switch, hardened with as many industry standard interfaces as we can. Where an industry standard interface exists, we try to use it. We don't purposely make pink screw connectors, as they call them, to try to trap you into a sole source. We try to work in an open source type of environment, and you'll see Amphenol through our Open.Tech be a lot more active in the industry standards. Because of our decentralized nature, we hadn't been as much, but we it's something that we're committed to doing now going forward. And really, this is about all I have. Our thoughts, what we're seeing right now, we have sister divisions that are extremely active in the data center and hyperscale data center world. And what they're telling me is that 85% of everything they're doing nowadays is single mode. So they're quickly abandoning multi-mode. That gives me a lot of concern, because we know that all the good, successful products that we have really have come from being able to leverage the scale of the data center industry, and they drive the industry. And so, are we looking at shifting to single mode? The Navy, the U.S. Navy, pretty much just wants single mode. They don't want any multi-mode. So we're having to build connector systems and modulators for that. Expanded beam. Do you guys really want expanded beam? I understand the the reason why you want it in some cases, but there's also some drawbacks to it. And we like to educate the customers on both. We don't see a lot of wholesale adoption of expanded beam right now, but we're certainly there to support it and capable of supporting it if you like. And recently there's been talk of CWDM and DWDM. Our data rates are getting faster and faster. We're adding more lines. And typical in the military world, the thing to do is you just add a pair, and you add a pair, and you add a pair. We're doing 192 fiber connections today, and that's while that's manageable, it's a lot. And you start looking 30 years ago, the telecom industry was already doing DWDM and CWDM. Is that something that you want? There's a lot that needs to happen to make that happen in the space that we have with the volumes that we have in our industry. So that's it. That's really the extent of my presentation. I'd like to hear your feedback, take any questions that you like.